The cities and states of the West are in a very severe drought. Some sources say it's the worst drought in 500 years. Weather patterns are changing. Lack of late winter snowfall has drastically reduced the amount of runoff that fills reservoirs that feed most of the large cities of the Southwest. Snowmelt provides roughly 70% of the West water flow. During the last century, the snow has been melting too early as winters have been getting shorter. Take a look at what's happening to Lake Powell. It's one of the largest man-made reservoirs in the world, and it's at its lowest level since the reservoir was created. Lake Powell will be down to its dead pool level within a few years if the drought and runoff trends continue. There are no new natural water sources to be developed, and there's only so much rain that will fall. Western cities and communities are growing, but there are no untapped water sources to meet the growing demands on aging infrastructures and limited water supplies. We simply have to do all in our power to conserve and extend our precious water resources, the lifeblood of the West. We'd like to show you a cost-effective conservation system that can be implemented fairly easily and inexpensively when compared to building more dams and constructing long pipelines. This method is water reuse, or wastewater recycling. Many larger cities in the West are already implementing this practice. However, smaller communities and private developments mistakenly feel that it's too expensive to develop a water reuse plan. Well, we're going to show you how a small community has implemented a water reuse plan by the use of a membrane bioreactor system manufactured by Zenon Incorporated. The facility was built here in Oakley, Utah, a sleepy little community at the foot of the Uinta Mountains, just 20 minutes east of Park City. The city of Oakley had two water problems. First, they received a notice of violation that their existing discharging lagoon treatment system was out of compliance with the Utah State Discharge, and they had to find a way to fix the problem. Second, the town was facing a water shortage. While the Weber River runs through the community, all the water rights within the river are owned by large communities along the Wasatch Front. They needed to develop water in order to handle growth in the community and supply additional irrigation water to a brand new park area that included new professional rodeo facilities. After researching different treatment technologies, the town settled on a relatively new technology called a membrane bioreactor. This system uses the activated sludge process to clean up wastewater, but eliminates the need for clarification by immersing ultrafiltration membranes right into the activated sludge tanks. Oakley selected this process for several reasons. First, it has a very compact footprint, and it can be housed in a building right in town. And because it requires less than half the space of other technologies, land purchase costs are greatly reduced in an area like this, where land costs are relatively high. Second, being an aerobic process, it's virtually odor-free. Third, it creates an effluent that allows not only compliance with any permit the state might require, but also produces water that far exceeds requirements for water reuse. Fourth, because of its long holding time for solids, it produces less than half the normal amount of biosolids or waste sludge seen in conventional activated sludge treatment systems. And fifth, because it does not use clarifiers, its operations are very simple and it does not require full-time operators. In the summer of 2002, the town pulled together loans, grants, and its own reserves to start construction of the $1.7 million facility that could treat up to 250,000 gallons per day. And here's what the town of Oakley has constructed. Now, within this building that looks a lot like many of the barns in the area, Oakley is using the Zenon Z-weed system. After operating for almost 16 months now, the town has not received any complaints, and most people don't even know that there's a wastewater plant in there. Let's go inside. I'll show you how this unique system operates. First, let's talk about the heart of the system, the Z-weed membrane. Now, here in my hand is a sample of a very tough, hollow fiber membrane. And just like the microchip is at the heart of a computer, the membrane is at the heart of a water treatment plant. Membranes have evolved in much the same way as the microchip, from small niche applications to large, cost-effective multi-use systems. Let me show you how it works. The water is pulled through the surface of this ultrafiltration membrane and the solids are left behind. With a nominal 0.04 micron opening, all bacteria and many viruses are prevented from passing through. Thousands of these string-like membranes are molded into cassettes through which the water is collected. The membranes are backwashed and air is bubbled up through the membranes to help keep them clean. The cassettes are dropped into frames right in the tank. This is the tank that the membranes are dropped into, and it's full of activated sludge. The membrane cassettes are submerged, and then air is bubbled up through them. Now over here is the influent screen. Screening is a very important step as it removes inorganic material that might harm the membranes. This is a 2mm band screen that's made by Jones and Atwood. After it leaves the screen, the water enters into the anoxic zone, or the zone without oxygen. The anoxic zone, where the green pipes are, accomplishes 3 important steps. First, it reduces the nitrogen in the wastewater, a pollutant which can harm groundwater sources. Second, by reducing the nitrogen, it saves energy by biologically stripping the oxygen from the nitrate molecule. And third, it restores alkalinity in the water, which allows for the reduction of ammonia, a harmful pollutant to rivers and lakes. Just beyond the anoxic tanks are the aeration tanks. Fine bubble diffusers break up the air into very small bubbles at the bottom of the 12-foot deep tank that allows for the natural reduction of the organic material in the water. Because it stays aerobic, this entire process is virtually odor-free. Here around the backside of the concrete tanks is the piping that delivers air, removes water, and delivers backwash water periodically to the membranes. All this is done automatically and is controlled by programmable mini-computers that are very reliable and robust. The vacuum created for removing the water through the membranes is only 3 to 4 psi and can easily be created by normal centrifugal pumps like these here. Backwashing occurs every few minutes for a few seconds at a time to assist in cleaning the membranes. Depending on the hardness of the water being treated, chlorine solution is used to backwash anywhere from once a day to once a week. Here at this plant, once a week has been sufficient. Once removed, the water is stored in a tank for the backwash process, and it also passes through the ultraviolet disinfection to ensure all bacterial kill, a requirement for water reuse. While the membrane pore size, a nominal 0.04 micron, prevents the passage of bacteria, this final step ensures that the water is bacteria-free and also kills most of the viruses that pass through. The ultraviolet units are sized for drinking water due to the clarity of the effluent and are a fraction of the size used for wastewater. Here you can see the difference between the water in the tanks and the finished product. Let's go ahead and take a sample into the lab and see how clear it really is. This is Doug Evans, operator of the system, lab technician, and a former mayor of Oakley. Hi, Doug, how are you?
Very good. As you can see, I was just checking some of the parameters that we record here to make sure that everything has been running right. As you can see, we can monitor the entire process in 3D on this computer, which allows me to view the plant wherever I can find a phone line. The telemetry system, designed and constructed by SKM Electrical, will even dial us on our cell phones when there's an alarm.
Hey Doug, I pulled a sample of the effluent. Could you check the turbidity of the water for us?
Sure.
What do you think it will be?
Usually it runs around 0.1 NTU.
Is that good?
Yes. In fact, in my full-time job with Mountain Regional Water of Summit County, I seldom see drinking water turbidities that low.
Wow.
There, 0.1.
So Doug, do you have to spend a lot of time operating the plant?
Either I or Bob, the other part-time operator, spend only about a half hour a day watching the plant, checking the plant in the evening. We also spend about 3 to 4 hours on Saturdays doing routine maintenance.
What about energy costs?
Energy costs run about $800 per month, which is only a fraction of the energy costs we experienced with our aerated lagoon system that we had in the past. Our chemical costs only amount to about 1 drum of sodium hypochlorite every 6 months.
So who are these guys over here?
These are our pet fish.
Where does this water come from?
This water is the treated effluent from our plant. It flows through here continually. All we really need to do is feed these fish once a day.
And how long does it take to get from a home to this clear state?
It only takes about 4 to 6 hours.
You're kidding me. That's it. I mean, I've never seen an aquarium this clean before.
Hi, Brandy, this is Scott Rogers, the president of AQUA Engineering. His firm was the company that designed this plant and ensured that the construction and startup flowed properly.
Wow, what a pleasure to meet you, Scott.
Same here, Brandy.
You know, I'm really impressed with everything we've seen so far, but how clean is this water really?
Well, compared to a normal wastewater plant, it's very clean. There's some parameters that we test frequently, like biochemical oxygen demand and total suspended solids. We also test for bacteria, fecal and total coliform, and since we've started the plant, we haven't had any of these show up in the water. I'd like to think it was because Bob and Doug are such great operators, but I think it's mainly because of the technology that we're using.
Wow, that's very, very impressive. So you really like this technology then?
We think this is the technology of the future. In fact, in our firm, we are currently either designing or overseeing the construction of several membrane bioreactor plants. Because of the small footprint that this plant has, we're able to locate a plant like this right in the middle of a community and scout or mine the wastewater from the sewer line to be used for irrigation on either parks or golf courses.
That's fantastic. Doug, do you feel like you made the right decision for the town?
Yes, and I am really proud that Oakley City was progressive enough to make this type of a decision and choose this type of treatment. And I'm convinced that this is the treatment technology of the future.
Thank you very much, gentlemen. It's been very enlightening.
What you've seen here today is not only a great way to conserve water, but it can also go a long way to assist communities to preserve the valuable water resources that they have. The Zenon ZeeWeed process is the way of the future for wastewater treatment and recycling. Thanks for taking the time to watch our presentation. We hope this helps you discover new ways to drought-proof your community or development and show you how we can all work together to preserve the lifeblood of the West, our water.